Right. So, starting quarter 2, 4-1, quadratic relations and systems of equations. I should have sent myself a PDF of this, but oh well. I'm sure day 1 will be chock full of errors. So just starting the note off, now that we've spent a bit of time working on quadratics and more importantly completing the square. So we're going to be jumping in, working with circles. We're going to be using the same techniques that we used when completing the square. I saw when I was grading your guys' test lots of shortcuts and errors that you were making when you had to complete the square on that mini test last week. That was the last question. One of you, I was gracious enough, you still used the quadratic formula. I gave you half credit. I should have given you nothing. You can thank me later. Okay? So a circle is defined. A circle is defined as the set of all points equidistant from another point. So the equidistance is what creates the radius. So if I have my thumb, so once again, this would be helpful if I had an actual webcam, right? So my thumb is the center of a circle. The distance from my thumb to my pointer finger is the radius. So all points the same distance from here to here from my thumb makes a circle, right? Because right here I'm starting, I just kind of twist, right? I'm keeping the distance between my thumb and my pointer finger the same. And that's always going to create a circle, right? Because my thumb's stationary. So we learned earlier that the formula for a circle does not differ from the distance formula. The distance formula. The equation of a circle centered at the origin with radius r is x squared plus y squared equals r squared. X squared plus y squared equals r squared. That is a circle. That is a standard form of a circle centered at the origin. Standard equation of a circle centered at the origin. So in other words, what's the center of it? 0, 0, because that's the origin. Thank you, Amanda. 0, 0. But we can have the actual standard formula. So we have that right underneath that on your page in front of you. And that's, so this is just that way, if you're watching it later, I suppose. I did. If I didn't, oh well, first day with an error. Okay. Standard form centered at origin. It's really funny. I've made plenty of recordings. Those of you who've never had me last year, whenever I'm absent, I do my lesson in an empty classroom for you guys, and then this is what is played by the sub. So you don't get a day of like, hey, free day worksheet, yay, no, because it goes on. So, all right, standard form of circle centered at the origin, and it's really funny because you guys think I write fast or you write slow, but when you actually aren't writing along with this and you're just watching the video, it's really funny. You're just like, oh my gosh, can he write any slower? You actually really feel it. So now we have standard form of a circle centered at another point. No, it's in your note, Tim. Standard form of a circle centered at HK. Some other coordinate on the coordinate plane. Some other coordinate on the coordinate plane. And all of a sudden we get our more complicated looking formula. Huh? Sure. All right. We okay? Bueno? Let's get the first example in. Let's get this first example in. So according to your note page, write the equation of a circle centered at 3, negative 2. Radius 6. So right there in your note says, example, write the equation of a circle centered at 3, negative 2 with radius 6. All we're doing is we're using this formula right up here, and we're plugging it in. Okay? Very easy. So what is 3? Go again. H. 3 is H. What is negative 2, Aaron? K. Dylan, what's 6? R. Not very hard when the word radius is sitting right there, right? So I literally take these values and I'm going to substitute them into my top equation. So I get x minus 3 squared plus y minus negative 2 squared equals 6 squared. I'll do one step of simplification, and then I'm done. Nothing I can do with the first half. Meadow, how can I simplify the next part of it? Y plus 2. Negative times a negative makes a positive. Go ahead, Jaden. What's 6 squared? 36. And we're done. That is the equation of a circle centered at 3, negative 2 with radius 6. And this should still, let's link it back a little bit to the last couple of assignments. If it's in parentheses, what do we do? Somebody raise their hand and tell me. When it's in parentheses, what do we do with transformations? With transformations, what do we do in parentheses? Josiah? Opposite. Okay? X. X. Is X horizontal or vertical axis? Horizontal. So this is telling me to move it 3 to the right, because it's in parentheses, we do opposite. Y is what type of axis? Vertical. So I'm moving it 2 down. It's in parentheses, we do opposite. Okay? So we're taking our normal circle, which is way up here. Okay? This one's not shifted left or right, up or down. Right? So we're just moving it. We're taking that circle that was at the origin and moving it wherever we'd like it to be. Let's go ahead and take a look at it really quick on Desmos, and then I'll let you guys. So, we had x minus, what was it? Help me out, guys. 3. X minus 3 squared? Yes. Plus? There we go. Okay. And here we have our circle then. It's been shifted 3 to the right and 2 down, and the radius of it is 6. Okay. So, try 1, 5, and 6 in your workbook right now. 1, 5, and 6 in your workbook. It's on 4-1, Tim. You can find 4-1 without a page number. Why don't you have your workbook out yet? You on? Question? Sydney, all done? Too easy? I feel like I'm invading another country by walking over here. Yeah, that's right. America. That's why I can do it. Hey, you can laugh at that later too. All right, just another few seconds. It's in your notes. 13156 in bold. Hold on, Amanda had a question. Well, you don't even have to do that. I'll show you guys. But yes, you could use the distance formula.
Mr. Bates, can I tell period 6 that to solve an exponent, it's just the exponent over the number? So
No.
we win. Darn it.
Yes.
Mr. Bates is
What number are you pointing at?
Number 2. I'm saying.
Yep. I'm not going to pause in between. Yeah. No. They get their own too. Okay, let's bring it back together. Number 1, Adrian. What do we get? Okay, so then you want to put it in the formula for me, Jayla? What do we get? Minus what? Minus 9. Here. You could fix it right now. Equals what? 10 squared. Which we can just go ahead, right? And we don't need to put, like, since there's only one more simplification step in this, and that's to write the exact same thing, but make it equal 100. You know, we don't need to necessarily write it all again. Or, yeah, or copy paste it. Okay. Then I said 5. Let's do 5. Let's do number 5. Yes. Madeline, yeah. This one takes a little bit more, so I would expect a simplification step. That's going to be x plus 3. We can actually do, what is y minus 0? Just y. $36. Okay, we good? Right. You are correct. I shouldn't have said right. Shayla? Huh? Okay. So Jaden asked the question. Aaron? Jaden asked the question, so this one would just be to the left. That's correct. And if we think about where's negative 3, 0 on the xy axis, right, it's just to the left of the origin. So yes, this one's only been moved to the left. Okay, last one for this set. Sure, Malika? Uh-huh. Oh, plus, yep. Oh, so we're getting... No, you're fine. Oh, it'd be minus negative 1. Because the formula itself has the minus, and then we plug in the negative 1. Correct. Yes. So 64. Okay. 8 squared, 8 to the second power, which would be 64. Whoop, that's 9 to the square. Okay. Okay. That's one of the things I've noticed in when I do record these and I play them again. I shush a lot without you guys hearing. So I need to stop that on my own, so that way I don't like having habits. Yeah. We good? So let's go to the next example.
Wait, so this one would go to the right 6 and down 3?
Correct. We need to stop having side conversations, is what we need to stop doing. As you guys watch these, I want you to understand how much education is lost because of the fact that you guys cannot stay focused. Yes. No, not terrible. It's okay. Small mistake. Just waiting. Ladies. Okay. So we have another type of example. So Madeline pointed this out. I had to do 1, 5, and 6. So 2, 3, 4 are different. But let's get an example like 2, 3, and 4. So in our notes, we have write the equation of the circle centered at 4, 5 and containing the point 1, negative 1. So that's the question we're going to do in just a few minutes. But let's go ahead and get the one from our notes in. So center will be at 4, 5, and it contains the point 1, negative 1. I want us to think, first of all, visually what this would look like. Yes? That is what we're going to do, yes. But I want you guys to think about what this is looking like first, so I'm going to draw a quick little coordinate plane. Maybe a little off center since I'm going through the point 4, 5. So there's the center of my circle. Is everybody okay? There's 4, 5. Okay? And I want this circle to go through the point 1, negative 1. So what does this line represent? The radius. The radius. So therefore my circle, I know, that's not going to work out. You know what? I've got tools. Rotate that a little bit so I can actually fit it. Okay? So if I were to, there's my best attempt. I know it's a rough sketch here, guys, but there's my best attempt at drawing a circle that goes through the point 1, negative 1 is centered at 4, 5. So there's what my circle would look like. And every single radius it's the same. The radius is equal all around. So that's what I'm trying to get. And Alexa, you're the one who said it a second ago. Alexa was spot on what we do. We need to find out what the radius is. The radius, there are two ways to go about it, and we are doing the same thing. I want that to be very clear. We're doing the same thing. Earlier, I'm hoping because Amanda had geometry with me last year, she remembered. To find the radius, she said, can't I just use the distance formula between 4, 5, and 1, negative 1? If I find the distance between 4, 5, and 1, negative 1, isn't that finding the radius? Yeah. Yes. Okay? But Alexa, who didn't have me last year, she said, I've got this cool formula. Let me write it on the board again, even though it's right there on your notes. And yes, she said the formula was cool. That's the way it went in my head. Nobody can convince me otherwise. Thank you, Samuel. All right. Alexa said we have this formula. Isn't this H and K? Yeah. And what are those? X and Y. Can I just plug all those in? Yeah. Okay. Let's do it. So we get 1 minus 4 squared plus negative 1 minus 5 squared equals r squared. So I just plugged in. No, but we're going to find it in a second. That's the only variable now. We will be after I go through the example. This is the example in your notes right now, Malika. I'm going to scroll this up a little bit. All right. Tim. Okay. Tim, what's 1 minus 4? Squared. Okay. Tim, what's negative 1 minus 5? Negative 6 squared.
36.
Okay. So this is a longer problem. It requires scratch work. Okay. I'm going to square root it, but this is going to reduce. We have to bring in our square root reduction skills. So, square root both sides. I'm going to continue it right up here. R equals the square root of 45. I'm not going to put plus or minus in front. Somebody tell me why. Logically, I'm not going to put... I move from a square to a square root. Whenever I move from an even to the even root, I put a plus or minus in front, but that's only when I'm working with pure math. How come I'm not going to put plus or minus in front of this one, Sydney? Because I can't have a negative radius. So it doesn't make any sense. So now, what perfect square resides within 45? 6 is not a perfect square. 42 is not either. 6.5. 9. 9. Thank you. 9 is this perfect square within 45. So 9 times 5. What's the square root of 9? 3. All right. Okay. We've reduced. That's our radius. However, what is the question, Samuel? Before you ask me, is that the answer? What was the question? Write the equation. Now, you take the good, you take the bad, take it all, and then you have the facts of life. But we actually didn't need to do that. We could have left it 45, and I'll show you why in a second. Okay? So we're going to go back to that formula. Now it's just like It's just like numbers 1, 5, and 6. Just like 1, 5, and 6, we are simply substituting numbers. So Michael, give me the formula of the circle centered at 4, 5 with radius 3 square root 5. You're doing the same thing as we did on 1, 5, and 6, but with what are 4, 5? H and K. 4, 5 are H and K. So give me the formula starting it off. Equals 3 square root 5 squared. But before I write that down, I'm not going to write down 3 square root 5 squared and then watch you guys square it out. Because the formula is x minus h squared plus y minus k squared equals what?
R squared. So you just need
What's r squared? It's 45. It was given to me way earlier. Good job. 45.
so you just have to figure out what the R squared equals so you can substitute.
Yes. All right. Now, 2 seconds here, guys. At least 5 seconds. Yeah, this is the final part of it. The final formula. So, I'll wait. Adrian, you'll be my metric. When your pencil's down, I'll know you're done writing, and then I'll say pencils down, eyes up for everybody. Nice haircut, by the way. Okay. I was growing my hair out, and then finally, yesterday, I shaved it back down. So. Yes.
So it's not that it's 45 squared?
Just 45, because it's r squared, and r squared is 45. So, pencils down, eyes up, no talking. I want to point something out. I want to look at Amanda's method. Amanda said, let's use the distance formula. The distance formula, don't write this down, that's why I said pencils down, eyes up. The distance formula is distance equals the square root of y2 minus y1 squared plus x2 minus x1 squared. Okay? There's the distance formula. And so she said 4, 5 was, I don't know, let's say 4, 5 was x1 and y1. Okay? And then she said that the point that it went through, which is 1, -1, was x2 and y2. And so then she would have said, instead of distance, this is all what my radius is equal to. And she would have said y2, -1, minus y1, 5, squared, plus x2 minus x1 squared. I want you to look at these two things. They are. The equation of a circle and the distance formula are identical. They're the same thing as the Pythagorean theorem as well. So, once you know one, you got them all. So, let's go ahead. I want you guys to do numbers 2, 3, and 4 in your workbook.